Well, good afternoon, everyone. Can you all hear me okay? Is that coming through? Yep. Okay, well, thank you very much indeed for coming along to the session, and welcome to MIX. I wanted to get started just by showing some video. So let's just take a look at a video experience here. This is the Big Bucks Bunny clip that we saw in the keynote earlier, and let's just watch it. So this is not what I would call an archetype for an experience that I'd want users to see. So the quality is not wonderful. There's a lot of blocking artifacts, and you can see that the kind of playback experience that's wrapping this video is pretty generic. It's pretty kind of typical of something. Not a lot of care has been taken over it. So I want to show you an alternate experience and then spend the talk showing you how I managed to achieve that. So we'll come over here to the same server, and this time we're running IIS smooth streaming. So the server's back in Redmond. I'm not actually using a CDN, and by virtue of smooth streaming, I'm seeing much better video quality. And if I have problems, if my last mile connection kind of dips because I'm in Las Vegas and the server is back in Redmond, adaptive streaming, the IIS smooth streaming system will take care of it for me. So also on the experience side, this is a much more polished experience. This is a wonderful experience that the guys at Archetype, who are here with us today, have done a fantastic job on. Some lovely touches here, like kind of the animation easing on the scrub bar. Notice when I scrub how fast it scrubs, and notice also how you get that momentary kind of flash of a lower quality as it does the seek, and then all of a sudden we kick into the nice high quality. Then one of the other features that we have here is rather a nice animation for our playlist. And this is using the new 3D graphics stack in Silverlight 3. In a minute I'll actually show an example where I've got a number of clips in the playlist. And I click on it and it comes back. And then another feature that we'll see how to build later on is the commenting system. And this is a commenting system that I put together as basically a test to kind of see how extensible our experience is. And this is using Windows Azure on the back end, and it's allowing me to basically do kind of user-generated comments. And this is my one that I made earlier. Escape. So we'll see a bigger demo of this later on. Before we move on, quickly just show you hot off the press from Archetype. So this is actually what the playlist experience will look like with multiple videos. And here you see this nice 3D carousel. As I roll over them, I get this nice preview. So, we're really trying to put two things front and center here. The two things we're trying to put front and center: one, great encoded quality video, and two, a fantastic Silverlight experience. So with that, my name's James Clark. I'm a program manager on the Expression Encoder team. And as I mentioned, there are really two things I want to focus on in the course of this talk. Firstly, encoding and creating great content. We all know content is king, and content has to look great when we present it on the web. The second thing I want to do is to talk more about the experience, about the Silverlight, what Silverlight can add, and how we can really create a very compelling, sticky experience for our website. We'll also, at the end of the talk, focus in on the next version of Expression Encoder. I've got a couple of demos there for you as well. And a couple of other talks that I would like to point you to. I don't know how many of you saw Alex's talk, which was the one before this one, but that was a great high-level overview of the Silverlight streaming stack, and I'd advise you to take a look at it online if you get an opportunity. John Bocharov, who is at the back, will be doing a talk tomorrow on delivering media, and specifically talking about IIS 7. So if you're interested in smooth streaming and you're interested in seeing some of the scalability benefits to get from that, I'd highly recommend John's talk. And then finally, a gentleman by the name of Nick from Akamai will be delivering a great talk on ad integration and how to monetize your experiences. And I don't know if there are any encoding geeks here in the audience, but if there are, I've got a session on Friday where I'll be doing some kind of tech tips on Expression Encoder. So let's get started, and from a high level, what we're trying to achieve is a great experience, and as I've mentioned, there are several aspects to this. One, creating a fantastic application in Silverlight using tools such as Visual Studio and Blend. Secondly, getting great-looking content and encoding it in Expression Encoder or many of the other third-party tools out there. And then finally, delivery. So what I want to do is actually start at the end and work backwards. And I want to give you a little bit of context around the delivery so that we can then drill in and talk about encoding in the context of smooth streaming. So this is a slide that you may have seen before, and it just describes kind of some of the ways that media can get delivered. First off, progressive download, where the client basically makes a request on the server. The bits are delivered as fast as humanly possible back down to the client, and the client can consume them. This is kind of great because it's simple and it works with the internet, but has some downsides. It typically costs more. You typically get the bits as fast as possible, which isn't necessarily optimal. So along came another approach to streaming, and this is where we started to use a stateful protocol. And in this case, commands are issued from the client to the server, such as play or seek, and the server then delivers us a rate-limited stream over this stateful protocol. And that's fantastic. It solves some of the scalability issues in terms of bandwidth consumption, but in other ways is less scalable. You have to have specialist caches in your network. So the approach that we're taking now with IIS Smooth Streaming is actually kind of a hybrid approach that's almost the best of both. In here, we have intelligence in the client. So the client knows all of the streams that are available, and the client actually requests the particular streams that it needs. In this case, in this example, we're requesting a fragment of video at a specific time. The server goes out to the file, finds that particular fragment, and then returns that over HTTP. And this fragment is probably a 2-second long piece of video. So it's a fairly small file, and it's very easy to cache. So any edge servers or web caches will cache that file. We then come and request the second chunk of video, and exactly the same deal. We've actually asked for a different time. We go back to the server, the chunk is delivered, and it's ultimately delivered back to the client. And this pattern repeats over and over. So it's really, as Alex mentioned, not so much streaming as a succession of very rapid HTTP downloads. Now, the great thing about this is that if a second user comes along and the user requests those same files, it's a simple URL, it's a simple file on the end of that, and it will be cached and returned. And so rather than having to hit the origin server, we get fantastic scalability there. So the other component here to understand is really looking at the last mile and thinking about when we watch a video on the internet, most likely the experience that we get will be determined and limited by what our connectivity is. So in the top case here, I've got a piece of string on a telegraph wire. It doesn't have a lot of bandwidth. I've got a very fast, shiny PC. In this case, the experience that I get is basically going to be quality limited by the bandwidth that's coming in by the piece of string on the telephone wire. In the second example, I've got a nice, shiny Fios connection with 15, 20 megabits a second download, but I've actually got a netbook on the end of it. And because the CPU power on that netbook is not very fast, then my limit in this case is basically the rendering performance of the machine itself. And then in the optimal case, at the end, we have this sort of dream scenario of the Fios plus the super high-powered PC. And in this case, we just want the best possible quality. So really, the other thing to consider is that these things can be changing. You know, someone may be doing a backup on the computer, suddenly the load spikes, and suddenly we have a problem. And so therefore, we want to adjust the quality. So the solution that we're proposing for this is smooth streaming, and I'm not going to go into an awful lot more depth on this, but the things I want to call out is really we're focusing on solving the last mile problem. We're using multiple bitrate encodes to solve that, and that's really the thing that I'm going to be focusing on for the next 20 minutes of this talk, is how we create these multiple bitrate encodes. And then also scalability, both in terms of the resolution smooth streaming can deliver, as well as the internet basis of that. So as I mentioned, multiple bitrate encoding is really the topic of the next 20 minutes. So let's switch over. Takes a few seconds to switch, which is designed to give me heart failure, I think, but it will kick in a second. While it does that, I'm taking the opportunity to load up my demo. So what I'm going to show you here is actually just the multiple bit rates that we're going to be creating. So I'm opening up a a smooth streaming file that I've created already, and I'm just going to play it back. This is kind of a diagnostic tool that we use, and the features that I'm showing you in this tool will be coming in a future version of Expression Encoder. What it does is allows me to crack open the ISMV files, which is the smooth streaming format, and look at my different qualities. So you can see here's the lowest quality, and as we click up, you can see the resolution is improving. And hopefully what you'll notice is that the actual kind of perceived quality of the images at each resolution is roughly the same as we step up. And we go all the way up to a 720p HD version, which looks pretty nice. So that is really the goal of what we're trying to create. We'll just switch back and talk through some of the steps. So some of the requirements that we have for smooth streaming, first of all, codecs. Well, if you were in Alex's talk, you'll have heard that today we're supporting VC1 and WMA Pro. The format itself fully supports H.264 and AEC, so you can expect to see that coming later this year. From a rate control perspective, at the moment we're dealing with constant bitrate encoding. We don't support VBR encoding, so that's one of the requirements. And also, as Alex mentioned, the container is a fragmented MP4 container, and this is primarily because fragmented MP4 is an easy format to parse, and because we're doing this in managed code in Silverlight, we want it to be as easy as possible. The final point here is that you have to have fixed length GOPs, and this is really, if you think about it, you've got these multiple streams, and we need to be able to switch between them on basically chunk boundaries. So I have my 2-second long chunk, and at the end of every chunk, I may actually want to switch to a different one. So for that reason, the chunks have to be the same length, and they also have to start with an iframe. So there are really 3 approaches that you can use for encoding to smooth streaming. You can start off with the preset that we ship in the box, and this has its merits, certainly. There are some quality tweaks that we'd recommend that you apply. Since we shipped Service Pack 1 of Expression Encoder 2, we've actually done some more work, and there are some changes that we might recommend for quality. And then finally, you can drill in and actually determine and set your own bit rates for every level. So let's just walk through and look at these. So the first one is the preset. This is achieved or used simply by selecting adaptive streaming underneath video in the profile menu of Expression Encoder. And this has the codecs you'd expect, VC1, WMA10 Pro, set up for 1-pass CBR. And it actually has 4 bitrate levels. These bitrate levels were used in the Olympics. So we've done some very large-scale load testing and quality testing with this. We're very comfortable that they offer a good kind of starting point. But they are limited to 480p. The next step is tweaking the defaults, and here we've got some recommendations or prescriptions. And basically, the clip that we've been watching, the Big Buck Bunny clip, has been exhaustively analyzed by Ben Wagoner, who's one of Microsoft's compression experts. And Ben basically drilled in and did some very detailed analysis, some very detailed QC work, and found this problem frame. And this frame is really a result of the fact that we're using CBR rate control, and you can see on the left, if we zoom in, there's an awful lot of blockiness, and you see a lot of loss of detail in the tail. The reason that CBR does this is because CBR can't see into the future. So if something unexpected happens in the future, the codec finds itself having spent all of the available bits that it has available, and it therefore has to crank the compression way up, and you get these blocking artifacts. With the tweaks, they get considerably better. And bear in mind that this frame is going past very quickly. So unless you analyze things, you tend not to see these kind of things very clearly. So a couple of tweaks for you. Scene change detection. And so scene change detection brings to CBR encoding the ability to look forward in time by 20 frames. And this is great for kind of catching things like flashes or extreme changes of content, cuts, other things like that. So despite the fact that we're using CBR encoding, we're actually getting some mitigation and some kind of future seeingness for the codec. Adaptive dead zone is a very scary concept, and I suspect that if you're at the party tonight, you may find me in the adaptive dead zone tonight. Fundamentally, this is a technique that reduces the blockiness, so it tells the codec, rather than going very blocky, go soft. And we found, again, in our testing that this is a good thing to turn on. A couple of other ones that I won't go through in detail. And these are all settings that we're going to make available in a preset. So we're effectively going to upgrade the preset that we ship with. The final one is to stretch, not letterbox. And the reason for this is, if you think about it, you have your multiple levels of video, your multiple bit rates and multiple resolutions. It's possible that at any one of those resolutions, you may be very slightly off by a few pixels. And if you have the default setting here, you're actually going to end up with very thin black bars. So we definitely recommend a little bit of distortion of the aspect ratio by using stretch. So those are some of the kind of prescriptive things we tell you to change outside of the preset. We'll now move on and talk about custom bitrate levels. So in expression encoder, you can have up to 10. You can have as many or as few as you like. Typically, we would recommend something in the order of 6 or 7 as being a good sweet spot. The way that we would recommend you set these bitrate levels is look at the top bitrate that you need. Look at what your content is, look at what who your audience is, and figure out, should we be tapping out at 2.5 megabits? Should we go to 5? There's no point in really adding bit rates that no one can play back. So that's kind of one constraint. The other constraint is, what's the minimum that you want to offer? In terms of how you space these, linear is okay. In other words, spacing them evenly. What we tend to find is it's actually more efficient to space the lower bit rates a bit closer together. And the reason for this is there's much more variance at the low end of the bandwidth spectrum. You get much more variance. So clustering them together down there helps out. So quick example here. We're wanting to do an HD 720p encode. So we're picking a maximum bit rate of 250 kilobits a second, minimum at 300, and then 7 levels. And you can see on the spacings that at the bottom, they're kind of linear. And as they go up, we space them out a little bit more as we go from 1700, 2100, 2500. Then the tough part, once you've chosen your bitrate levels, the tough part is actually how do I map that onto resolution? And when we looked earlier at the simulator, we saw each of those levels, the quality kind of looked roughly the same, even though the image size was smaller or bigger. And this is really where the art comes in. And so to cut a long story short, the easy way is just to use a tool. And the tool that we've currently got is a tool that Alex Zambelli wrote that allows me to define, here are my constraints, here are my resolutions, here are my levels. Go figure it out for me. And this does a great job. It also handles the notion that your resolution must be divisible by 16 to get the best and most efficient encoding. So this is a tool that's on the internet. You can hit that link, put your resolutions in, and it will actually spit out a preset that Expression Encoder can then consume. So, excuse me, a case study for this, smoothhd.com, which is a website that showcases smooth streaming. And this went live back in October, and it features a whole bunch of content that was encoded. So this was all done with Expression Encoder 2 SP1. You can see here the audio, we were using WMA Pro, very good low bitrate audio codec there. And you can see towards the bottom, 2-second closed GOPs. What this means is every 2 seconds we can change to a different bitrate quality, and a single chunk that's traveling over the wire is going to be exactly 2 seconds long. The profiles that we use for the Smooth HD website, you can see the top resolution was 1280 by 720, 2.5 megabits. And we went down, we had 6 levels, and we went actually down to 400 kilobits in this case. There was some more challenging content, and this content was challenging both in the case of having very high motion, which typically gives a codec a problem. And secondly, there was also some very dark content, and dark content is typically hard to compress. So for these cases, we wound the bit rate up by between 10 and 20%, and this is a typical recommendation we'd make. If you have particularly challenging content, crank your bit rate up a bit, and then potentially use some of the special settings that are tailored to things like dark content. So now we'll do a little quick demo of configuring these settings. It does love to do that to me. So I'm just going to bring in my Big Buck Bunny source. And this is a losslessly compressed source. It came from the original animation files. It's synchronized audio and video. And we'll just quickly go and set the settings up. And as we do so, we'll just get a bit more insight into actually how smooth streaming works. So we'll come through, and the first thing that we'll do is make sure that we're on CBR. In fact, sorry, the first thing I'll do is pick the 720p preset to give me my 720p resolution. Then we'll come down and as we mentioned, select constant bitrate encoding. We want our buffer window to be 2 seconds, and our buffer window is controlling the chunk size and the GOP size. So by setting a buffer window of 2, I'm saying I want 2-second chunks. And then we'll set our top bitrate at 2.5 megabits a second, which is what we chose. Now, at this point, I could go and add more streams. So I could click on the Add Video Stream and then go in and type the numbers in. What I'm going to do to save a little bit of time here is apply a preset. And this will add all my bit rates for me. So you can see for every resolution, I have a width and a height and a bit rate. And when I actually perform the encode, what's going to come out of the encoder are 6 different files, 1 for every bit rate. So we'll just quickly now come down and talk about the advanced settings. Now, there are some important ones that we have to use to create a smooth streaming file here. The first one is actually we need to tell the container to be smooth streaming, which I forgot to do. So we'll come down here and say container output mode IIS smooth streaming. Then down at the bottom, we need to set our output mode to be elementary stream with sequence header. And by the way, you pretty much never go and do these manually. I just want to do it purely to walk you through and explain them to you. So elementary stream sequence header is a setting necessary to have the chunks be independently decodable. So at the beginning of every chunk is a sequence header, and I can literally take any one of these 2-second files and play it back on its own. So then closed GOP. Closed GOP means that every chunk is completely independent. If we don't have that turned on, it's possible that one chunk actually has a relationship or a dependency on another chunk, and that's bad. We want the chunks to be independently decodable. So we say closed GOP. Adaptive GOP is bad because it varies the length of a GOP. And as we've learned earlier, we don't want that to happen, so we turn that off. Scene change detection is good. This is the look-ahead feature we talked about earlier. This is a quality thing that will really help our CBR encode, so we will have it turned on. And from there, we're pretty much done. So at this point, we could apply some of the tweaks that we talked about earlier, the adaptive dead zone, that scary thing, and we'd then be good to go. So what we'll quickly do is open up one we made before and quickly click the encode button. And this is now actually the file that I showed you at the beginning of the talk. So this is the one that was actually uploaded and we played back. And you can see in the bandwidth simulator here the great quality. If we come in and vary the bandwidth and limit the download rate artificially, you'll then see the quality drop off. And now we're playing one of the lower bitrate streams. So this is smooth streaming in action. There's a feature in Expression Encoder where you actually get to preview this without the need for IIS. So if you have an encoding box, you feed some content in, you can just hit encode and see the result, just like we're doing right here. So that is my first demo. So a couple of things you can do for quality. If quality is something that is really important to you and time doesn't matter, then you can increase the video complexity. You can wind it up to 4 or 5. You can also improve some of the motion estimation tuning. You can use the adaptive true chroma setting. I think that has the effect of making the encode time go up by a factor of 5. So it really is, you're paying for your quality, but it's definitely worth it. And you can also similarly use a different match method for that. We mentioned before another important factor, if your content is complex in any way, if it has high motion or if it's very dark, then you may want to increase the bit rates that you come up with. And similarly, you may want to turn dequant on in that case. So that's kind of a whistle-stop tour through encoding. What I want to do now is talk about the actual application creation process. So this is a little bit of a thunk from the world of bit twiddling to suddenly the world of Silverlight development. So any developers in the audience, you're now going to see some code. So just as an intro to this, we've noticed and observed how player experiences over the last several years have really grown in the polish and kind of, a lot of focus on user experience. We see branded experiences, and we start to see features emerging in players that are more akin to applications than just media players. And we saw, for those of us that were in Alex's session, the great demo of Essentia, where we had kind of commenting and rich features built in there with PowerPoint slides. And the reason that this is important is because we want to differentiate our experiences. we start off with a baseband experience with some pretty blurry, poorly encoded video. We then add to that, generic playback controls. And then if we want to really spend the time to differentiate ourselves, we'll go in and build these really rich experiences, such as the one that the archetype guys put together for us. In terms of how you go about approaching to develop this stuff, there are a couple of starting points that you can use. You can use an expression encoder template as a starting point, and that's really just like the one-click solution. You import the video, press a button, and out comes an experience. If you want to build something custom, then a couple of opportunities here. There's the expression media player control, and that's the one that we're going to look at right now. There's also a great bass player from Akamai, and this is an open source player. It integrates really well with the Akamai Adaptive Edge service, so it has some kind of service-oriented features built into it. And there are a bunch of third-party Silverlight media player controls as well, and some open source stuff on Codeplex. So there's a whole bunch of choices here. Then for customization, there's obviously Expression Blend. We saw in the keynote this morning that on a Mac, you can now use Eclipse to build Silverlight. And there's a bunch of other third-party tools that fit in there as well. And in terms of some of the building blocks, you've obviously got the basic player itself, and then things like advertising, analytics. These are modules that you may or may not want to add. Social networking is another one that we'll look at right now. So we'll move on now and have a little bit of a demo of this. What I'm going to do here is actually take the expression media player control, and I'm going to show you how I can basically put it inside of a project in Blend. I'm using the next version of Blend, which is the Blend 3 preview that you saw this morning. And I'm going to show you how it's very easy to manipulate the skin and to kind of perform designer-oriented tasks. Then we're going to switch into Visual Studio, and I'm going to show you how we add the commenting system, the social networking feature. So we start off in Blend. We've got an empty canvas, and what you'll notice over on the right-hand side is I've imported some assets. So I have a video file, and this is an encode of our favorite Big Buck Bunny clip. And I then have a number of chapter keyframes, and these are frames that I want to display as a list to kind of allow the user to navigate through the video. So we'll get started in here, and we'll come into the asset library. And if we go over to custom controls, one of the built-in controls is media player. So I'm just going to select media player and draw it out. And straight away, I get my basic player experience. So if we go into the split view and have a look at the XAML, you'll see that this is just a single line of XAML. So all of the richness that we're getting is basically coming from that single line of XAML. So in order to see some media playback, he looks down at the keyboard, and it's nothing like the one he's used to. In fact, let's move over here. So what I'm going to do is just basically bring in an XML playlist that represents my clip and all of my chapter points. So I'll come into my snippet tool here and just grab my playlist XAML, and I'll come into my media player and paste it in. And when it does this, it's effectively, I can do this through the UI in Blend as well. If you have a look down, you'll see the category media, and you'll see down here a couple of things: GPU acceleration, which is a feature of our player, and playlist. So if we open that up, you can actually programmatically do this as well, but I'm using snippets for the sake of speed. So we can pretty much hit F5 on this now, and it will run. So with pretty much one line of XAML, I have a bootstrapped experience. I hit play, I see the kind of the download progress, I have a scrub bar and timers, and I even have kind of my chapter points which I can seek to. So this is great, it's quick and easy, but it's not very customized, it's not very differentiated. So let's now go and basically rip the UI out. So I'm going to right click on my media player here, and I'm basically going to create an empty control template for it. So for those of you not familiar with Blend, this may seem a little bit kind of, wow, there's a lot here. For those of you that know Blend, hopefully this will make some sense. So we have an empty control template. So now we effectively have nothing. So the first thing we'll do is come in and create a background. And we'll just set a kind of a dark gray on that. And we want the rectangle that we've created to stretch. So we just set the width and height to auto, and then we set the alignment to basically stretch in both directions. And now we want to add in the media element, and this is the rectangle where the video will be displayed. So one of the great features in Blend 3, in the preview that we have, is this parts display. And the parts display shows you, for a custom control like this, all the little prerequisite items that are required. If we scroll down somewhere towards the bottom, we'll see media element. And if we double-click on this, it will add a media element to our scene. Now, the cool thing about this is that it's also given us the correct naming for media element. And the way that these custom controls work is all down to what everything is named. So basically, that's a great saving. So we've got a media playback surface. Let's now add a play-pause button to allow us to control things. So I'm just going to double-click on this. Creates us a nice big button, probably a little too big. So let's just make that smaller. And now let's just align it down to the bottom left-hand corner. We'll give it a little bit of a margin. Notice that right now, if we zoom in a little bit, we don't have any graphics inside of that. So we'll add those in a second. But first of all, let's add the scrub bar. So we'll scroll down to our position slider. And by double-clicking in my XAML, it's basically inserting exactly what I need and giving it the right name. So again, we'll just set the alignment on that and set a margin. And so pretty much with very little effort, just with a little bit of double-clicking and working with the parts panel, we've got the basis of our player here. So if I hit F5 and run, I have a player, it plays video, and I have a scrub bar which actually scrubs the video. So this is embodying a bunch of best practices. There are some kind of tricks to doing sliders that you want to follow, and by using this base experience, you kind of get that for free. So let's just change the styling a little bit. What I want to do is fix up my play pause button. Let's give it some graphics. So we'll come down. And what I'm going to do is paste inside of my play pause button my graphics. So I have a pause symbol and a play symbol. And those things are named correctly such that when the media player switches between states, it's able to hide or show the relevant graphic that it needs to show. So that's pretty simple. What we'll now do is some styling. So I want my play pause button to take on a different style. At the moment, this is just a generic button style that you would get in Silverlight. Let's change that. We'll right-click on it and apply a template. And this, we're applying a resource to that button, which will give it a different look and a feel from the default. So I'm picking this resource called Expression Dark. I'm going to do the same thing for the slider. And if you look at the slider, if we just zoom in on it a little bit, notice how the thumb is kind of about to completely change appearance. So this is one of the benefits of the styling system in Silverlight, is it's very easy to make things kind of different. There you go. So next, what are we going to do? We're going to add the chapter support here. So I'm going to come in and paste in a button that's going to give me my chapter activation. So we'll come to our snippets and select our chapter button. And then we'll come in and paste this into our document. And this is giving me, in the top right-hand corner, you can see the little icon and button. And when we click on that, it's going to bring up our chapter panel. So, okay, and this is the last thing we're going to do. We're now going to bring in our chapter list box. We're going to set a width and a height on it. Run the application, playback, and you'll notice that at the moment we have a data template that's just showing it to us as a list. So what I think I'm going to do is move on, and I'm going to kind of jump forward in time and show you a sort of a more customized version of this, and we'll then go on and build some features in Visual Studio. So let's switch over to VS right now. And so I've taken the design on a little bit further. I've basically I've changed the aspect ratio to be correct, as you can see. You can see that my chapter icon is now fading out, and as I move the mouse, it pops up. When I click on it, you can see my chapter panel is appearing and giving me my seek functionality. It's slightly stretched, but you get the idea. And we can turn that off. So those are some of the tasks that you would do in Blend, and you can see, we could take this a lot further. We could start embodying 3D and really, put a lot more polish on it. But what I want to do now is transition over to Visual Studio and show us how we can customize it. So what I've done is opened the project in Visual Studio, and to get my commenting functionality, this is basically coming from a secondary DLL here that I've written. This is using Windows Azure Cloud Services. It's using the table storage in Azure for storing the comments. And I've written a bunch of controls for plotting out kind of timelines and putting markers and so on there. So we don't have time to delve into the details of that. For those interested, I will be posting a code sample on my blog, which I'll share with you at the end of the session. And what we'll do is focus on how we actually integrate that into our player. So we'll come down here, and I have my commenting player class. So this is really a derived class that takes the basic media player that ships with Expression Encoder and adds new functionality. What I've done in my XAML is where previously we had a media player object, we now have my custom commenting player object. So we're kind of ready to go, and now we can actually add some code and some functionality. So first thing we want to do is take from our commenting library the timeline control and also another button control that's going to be used to add the comments. So we'll come to our snippet down here, and we'll add our commenting timeline XAML. And then in my control template, what I'm going to do is paste that in. So now, in our document, we actually have this timeline object. It's got a well-known name, and it's also got some interesting data binding going on. So if you think about how you might build this, you've got two different timelines. You've got a timeline where you seek, and you've got another timeline where you draw these comments. And what we've done here is to use some data binding to bind playback position on our timeline back to our media player control. So that there are two data binding statements in here, and it's using template binding. So now that we have that in our document, we want to actually write some code and hook this up. So the first thing I'm going to do is create a couple of variables. So I'm going to create a button, add comment, and I'm going to create a commenting timeline. And what I need to do is actually kind of hook those up from the XAML. So to do that, I override a method called onApplyTemplate. And what onApplyTemplate does is when the XAML is passed to the control, when the control is initialized, it's an opportunity where I can kind of grope inside the XAML and find all of the different objects that I want to work with. So what we'll do is take our add comment button and assign that to getTemplated_child as button, and we then need to pass in the name of the button that we're hooking up. So if we just have a little look in our XAML, you'll see that the button's name is add comment. So I'll just paste that in. That's pretty simple. And then we'll do the same thing for the commenting timeline. Oops, I've missed a quote. There you go. So we've got a reference to our two classes. What we now want to do is to hook up some event handlers. So on the add comment button, what we'll do is on the click, what we want to do is add a delegate. And I'm going to use a Lambda expression to do that. And I'm basically going to say in that click, when the user clicks add comment, I want to send a message to the commenting timeline and tell it to create a new comment. So by calling this method, it's going to pop up the UI to add a comment, and we'll be good to go. The other thing I want to do when the user adds a comment is I want to pause video playback. So I'm going to basically say this.pause. The reason I can do that is because, if you remember from the beginning, we're actually in a derived class from Media Player. So we've got access to all of the methods and properties on Media Player. And I've missed out that guy there. So then the next thing is we're going to take our commenting timeline and hook up a different event. This time, when someone clicks on the commenting timeline and clicks on a comment, we actually want the player to seek to that moment in time. So to do that, we have an event on the commenting timeline called new position. And what we want to do to that is to hook that up to a handler. And in this handler, what we want to do, and again, I keep forgetting to do that, silly man. What we want to do is actually to cause the player to seek to that point in time. So instead of calling this.pause, I can say this.seek to time, And the time I want to seek to is passed to us in the argument. So if I say args.position, we should be good. So if I build this and run it right now, it's actually not going to do anything. And there's one missing thing that we have to do. And to explain that, I'm just going to go to my Windows Azure site here and just show you how the commenting system works. So this is basically a little test application running in the cloud. And inside of that application is a database. And inside of that database is a series of IDs. Every video that we're going to add comments to has to have its own ID. And you can see if we click on this one, it should show us the comments from the intro that I showed at the beginning. So in order to hook up this instance of the player, what I have to do is to give the video an ID. So basically what I say here is, what do I set it to? It's the commenting timeline. Commenting timeline.video ID equals a new GUID. And I'm just going to create a GUID very quickly, copy it, and paste it in. So in practice, if we were using this template in the real world, this GUID creation would be inside of the template, so that when I bring in a video and encode it, it would automatically assign it a GUID. But in this case, we're going to create it manually. So if we just run this now, hopefully we should be good to go. I'm going to hit play. You can see I now have my commenting timeline. My commenting timeline is currently empty. I have a button here, Add Comment. So we'll have a little, and I've put the thing on top. We'll do it at the beginning. So I click on my Add Comment button. The video pauses. I can put my name in. And add a comment. Now, when I add a comment, what happens is that's plotted on my timeline. It's also pushed up to Windows Azure on the back end. So if we come back to our little monitoring application and refresh, we see a new GUID has appeared, and we should see, with any luck, my comment appear. Now, what's kind of interesting about this is if I open up a different instance, I can actually do real-time commenting. So we'll just dock these windows here, and I'll copy that address and paste it in. And so now, if I come to this comment that someone else has made and just expand it open, I can now disagree. I can now honorably disagree. And what will happen in a few seconds is, in the instance on the right, with any luck and a following wind, the little beacon will start to flash to tell us that a new comment has come in, as it does right there. And you'll notice in the list box that comment has appeared. So this is quite cool. It's kind of a proof of concept, and if you're interested in the code, I'll be making it available later on. I could probably spend the entire session drilling into how I did it. So sadly, we just get a little glimpse right now. So the final thing I want to show you with this is, what if I want to take that offline? We saw in the keynote this morning that Silverlight now runs outside of the browser as well as inside of the browser. Well, the good news is, if you use as your starting point the Expression Media Player control, you actually get offline support for free. So to illustrate that point, we'll come back into Visual Studio and just stop debugging for a minute. The one thing I need to do to enable it is actually edit the manifest file. So we'll come into Properties, open up the application manifest, and at the moment that's empty. So I have a nice little code snippet down here that will give me my offline support. So this is literally giving the application a name. I've called it Mix Breakout Player, giving it a title. You can also, if you want to, give it an icon by putting some pretty simple stuff in here. So we'll rebuild that. And the reason that this is now going to work offline is because in the media player control itself that we're using and that we're inheriting from, we've implemented this functionality. So in a future version, when the next version of Expression Encoder ships, this will work out of the box. I run my application, and it's working online. It's playing back. You know, you can see the various assets that we've got. We've got a video and some thumbnails. What I do now is to right-click on it, and I can say Install Mix Breakout Player onto this computer. And it asks me, just like in the keynote, do I want it in the Start menu on the desktop? Hit OK. Now, what happens now is quite nice, is that it actually figures out there's a whole bunch of assets it needs to download. There's a whole bunch of thumbnails. There's media files. And it will sit there and download it for me. When it's done, it will be available to me offline. You can see already it's appeared in the start menu. It's just downloading the video for me. So now I can take this, I can go on an aeroplane, I can take public transport with no Wi-Fi. I can come in and launch this thing offline. And you can see that even the commenting works. So one of the other aspects of what you may garner from this code sample is how you can actually kind of integrate with Windows Azure and have full offline support for your data. And you can see in here, there's my comment. You can see if we open up the chapters, they're all there. It's taken all the thumbnails, and it will seek and behave just how we like. And that was quite a demo, wasn't it? Let's switch back to the slides. Couple of points to take away from this. Do keep in mind your download size. As we add these advanced kind of pieces of functionality, it's very easy for the download size to get big. So you may want to think about how you can componentize your player and actually use multiple ZAP files and dynamic downloading and invocation. From a usability perspective, captioning is a very important aspect. We've looked at skinnability and how we can customize the look. And then a couple of other things, smooth streaming support. Obviously, if you're going to be using smooth streaming content, that's an important thing to consider. And then there are specific considerations for Silverlight 3, which we'll look at in a sec. So for Silverlight 2, some best practices. We recommend that you don't data bind your slider to the position bar or meter element. The reason for that is you get an awful lot of events, and you can get some serious problems. So we'd actually recommend a pattern where you use a timer to update your position bars. You also want to think about performance. So we encode our video at a specific resolution, and it's often easy to forget to set the XAML up to reflect that resolution. And as a result, if you do that and the player is resizing, you're going to lose performance. And you can see the others. I won't read these out, but these are pretty obvious. So for Silverlight 3, GPU acceleration is a new feature that's coming. This isn't enabled by default. So if you're working with meter elements, but effectively raw with a meter element, you do have to turn this on. You have to set a property on the meter element, the cache mode property, and you also have to set a tag on the object tag, an attribute, to turn that on. If you're interested in more on GPU acceleration, there is T17F, where SEMA will do a real deep dive into this. So I'd recommend that if you're into the graphics side. And finally, offline enabling our app, I think it's plain to see how powerful that is and how many new scenarios that will enable. So do consider that one. So we're going to finish up now by looking at the roadmap for Expression Encoder. We're actually going to take a glimpse at version 3 and see what's coming down the pike. So we'll just first of all focus on version 2. Couple of things to take away here. We do VC1 and H.264 encoding right now. So if you're doing kind of video for the web and you want to offer podcast downloads, that's something that's kind of built in. And internally in Microsoft, Channel 9 actually uses Expression Encoder for doing their web and device deliverables. We also do live encoding. And we've got an API. So if you want to integrate into a kind of more extensive workflow, we have a very rich object model that you can use. It's available both as a standalone product and as part of Expression Studio. And by virtue of that, you can get it in the professional subscription. And there's a free Express version as well. So we shipped V2 back in April of 2008. And then in October, we released a service pack. And this is where we introduced the smooth streaming support. So this was a pretty major service pack for us. And that's available on the web right now as a download. Also, the player templates that we were just looking at and the kind of the C# code you need to get started is all available in this service pack as well. So then next along will be V3. It's due to ship sometime later this year. We don't have a really firm date right now, but it will certainly be kind of roughly in line with when Silverlight 3 ships. And there are a couple of things that we're doing. There we go. That we're doing in version 3. So the first thing is we're adding much more extensive support for H.264. We're offering main and high profile support, and we're offering much more control over the settings, the width, height, bit rate, and so on and so forth. And we'll also be hopefully making this work with smooth streaming as well. So next up, we're also adding multi-clip assembly, and this is where at the moment you have the ability to add a leader and a trailer to your items. And now in V3, you'll actually just be able to connect an arbitrary number of items together. And this is a powerful feature. There's add insertion scenarios and others where this is very important and key. And then finally, on the live side, we're doing extensive work on our live encoder, not least of which is we're adding an object model to live. So if you have an application that's running as a service on your box, this is now actually going to be possible with Expression Encoder 3. And then the last area we'll talk about is screen capture. This is a feature that's present in Windows Media Encoder, and it's a feature that's very commonly requested by customers. So what we've done for version 3 is to take a very high-quality screen codec that has come out of Microsoft Research, and we will be incorporating it in the product. You can see from the figures that one of the key metrics on screen capture is I don't want my screen capture to be chewing up lots of my CPU. I want my CPU to be doing, what I'm actually recording. And you can see here that it's a very much more efficient codec than the old WM screen codec. And the other exciting piece of this, which you may or may not have garnered from the keynote, is that in Silverlight 3, we have support for something called a managed decoder. So we have an API in Silverlight 3 that allows managed code running on the client machine to basically decode any kind of media type and pass it as buffers into Silverlight 3. And so as a showcase of this, we've actually built a managed decoder for our screen capture pipeline. And this is actually pretty cool. We'll see a demo of it in just a second. Oh, it did it really quickly. Okay, so let's focus in on screen capture for 1 minute. What I'm going to do is open up a browser, and I'm going to browse to a web page, and I'm actually going to record the experience for you and then show you how I can play it back natively in Silverlight right afterwards. So we'll come in here and let's see. Load up my Accenture TV experience. So, I've been doing some research. I found this really cool app on the web. I want to basically record it and then show it to some colleagues. So what I'll do is come down to my Expression Encoder 3 screen capture application. I can do things like capture webcam feeds. I can also do things like capture the audio from the microphone or the audio from the experience itself. So we can come in and just say, I want to record the speaker audio. I think we'll just leave it at that for now. And then when I click the record button, I'm able to select a region, and it kind of sniffs out all the H-winds on the screen and gives me a little picker for them. And then I can just go ahead and record, and it gives me a little countdown here. And then it's now recording, so we'll come in and we'll come to watch it now. And I'm not hugely familiar with the site, but I shall try and make it do some cool things. Guess these are markers. And as it's going, you can see the little kind of corner angles are flashing at me to tell me I'm recording. So when I'm done, I'm just going to hit the stop key, and I'll just close down the browser. And so what it will do is load that up into a preview window for me. Just takes a couple of moments. And now I can play it back. So kind of maybe hard to see on the big screen, but the quality is really quite good here. So, the text quality is very nice. The animations are pretty smooth, and the video playback is actually pretty acceptable. And there is my experience. So that's kind of fine, but what if I want to actually show that to someone in Silverlight? So let's show you that part. What I'm going to do now is to save this out. And it's now saved on the desktop. So we'll just close down a few windows. And what I'm now going to do is open up a blend project. So I'm just going to open up a project called Titanium Media Stream Source. So this is actually a managed decoder for screen capture. If we have a quick look in the project, we've got a parser, we've got things for reading out the headers, and we've actually got the decoder down here at the bottom where it's actually going and doing the low-level codec functionality all in managed code. So I'm just going to hit F5 on this and run it. And I'm going to click open, and then here on my desktop is my demo screencap.tsc. And at that point, we start to witness the screen cap that we did. And what's cool about this is I didn't need to transcode it into VC1. It's playing video, it's playing audio, and this is available kind of effectively natively in Silverlight. In practice, what it is a bunch of DLLs that will come down with the player. But as far as the user is concerned, he's able to just witness that content without the need to install any additional components. This is a hugely powerful feature of Silverlight 3, and I think you'll see a whole bunch of third parties taking advantage of it, for adding some of the more esoteric media formats to Silverlight. So we've kind of covered 2 out of the 3 pillars, and the final one is actually kind of part 2, which is coming in John Bocharov's talk, and I would encourage you to go check that out. It talks about the IIS piece of the story and how smooth streaming scales to the internet level. So that's a good one. And that's pretty much the end. So, the main themes of this talk are, first of all, encoding great media, and secondly, creating rich experiences. So, go check the tools out. There's some great stuff that you can get on the web. If you're interested in more information, particularly if you're interested in the code sample that I showed, that's going to be on my blog. So, feel free to go download that. And that's pretty much all I've got. So I guess we'll open it up to questions. Yes, if you would like to ask a question, please use the microphone.
Hello.
Hello.
The screen capture stuff's already in what version?
So the screen capture stuff, basically the encoding part will be part of version 3 of Encoder, and that's going to be shipping later this year.